I've been asked to come here and give you guys a perspective as someone who used to work in the experimental sciences but now works in the computational sciences. So in particular, as part of that transition, I'm going to be talking about what lab notebooks looked like for me in an experimental environment and how I've tried to take that experience and adapt that to the computational sciences world. And so a lot of the content that I'm going to be delivering right now has been, I've arrived at that through conversations with many different people, and I've listed their names down here at the bottom to give them credit. So as I said, I have a fairly interesting background, a different background. My formal education was in experimental physics. I worked in experimental condensed matter physics labs for a number of years. I then decided to move to Chile, where I got to work on the summit of a lovely mountain that overlooked the desert and the Pacific Ocean for about 7 years. And in that case, I was working as an instrumentation and a systems engineer, specialized in adaptive optics. And then I decided that my life was too easy and I was enjoying it too much, so I decided to go back to school for a couple of years, where I studied mathematics with an emphasis in computational sciences. And now I stand before you as a scientific software developer in the mathematics and computational science, or computer sciences division at Argonne. So I do focus primarily on applications, but over the last couple of years I've been working on something that's more like a library. So as I go through this, I'll try to bring a little bit of both applications and library development to the talk. And so if you look at my background, you will say, yes, that kind of looks like I'm all over the place. I will tell you that that's not the case. If in reality, what I've always been working on is scientific instrumentation. So I started out concentrating on scientific instrumentation and hardware, and now I work in scientific instrumentation in software. And I will state that I do see scientific software really as a scientific instrument. I don't see it as being analogous to a scientific instrument in hardware. I really see them as being on the same footing. So I know that there are some people who do share that attitude, but I do know that there are other people who see or view their software in a different way, potentially as, let's say, just a tool. Okay, so then why should we be talking about experimental sciences at all at ATPESC? So rather than me try to write to you why I think it's important, I put up some quotes by people who've worked in this in computational sciences for a great many years. So the first one is from Carl Graziani, who's a computational scientist at Argonne. And he wrote an article on the BSSW webpage called HPC and the Lab Manager. And in that he states that scientific HPC is several young fields that on close examination have not really stabilized or optimized their collaborative processes in a manner analogous to that of more mature classical sciences. As a consequence, valuable science is often needlessly lost or left uncollected. So I think that sort of stands on its own. I will highlight, though, that that actually does reflect the experience that that happened to me when I came from experimental sciences to this environment of computational sciences. There were certain tools and processes that I was used to, and I wasn't able to find them. So for instance, lab notebooks, and I've been working for about 5 years now trying to figure out how I can adapt those processes to this environment. The next quote is from Catherine Riley, who's the Director of Science at ALCF, and in 2019 here at ATPESC, she gave a talk, and she said that practicing the scientific method properly requires good software practices. This is understood in the experimental community. The computational science side has had a historic problem with it. As we can see, it's getting better. So this is also something similar to what we heard this morning in terms of what David was talking about. But first and foremost, what we mean by good software practices, well, we understand it to be learn how to write good code, design it well, comment it well, document, and get it under test, right? And so when I talk to people in the computational sciences and in the theoretical sciences world, oftentimes they will refer to these practices as software engineering. And I get the sense that when they refer to it as software engineering, they're saying that this is something that other people do, right? This is some other's discipline. I might have to do this sometimes, but really it's outside of my normal work. And I can't disagree with that in a more strong way. To me, these are not really software engineering. These are really foundational, bedrock, general low-level science. They're not just good software practices. To me, they are good science practices, right? And I think that's important. And one of the aspects of this is I believe that the people who are going to be carrying out that high-level sciences need to take control and ownership over this low-level sciences, because they're the ones who know what needs to be done at a low level to prop up their high-level science so that it's rigorous, robust, and reproducible. I will also say that I think as someone who was, first did my formal education in the experimental lab, that I think there was a lot of effort put in to help me appreciate the need for these low-level general sciences. It's generally quite boring, It's not something that I want to do, but people, for instance, help me understand that it's necessary. In the case of lab notebooks, I can tell you I was quite stubborn. It took me probably about 2 or 3 years before I figured out really the utility of it, but eventually I got there. So I did design this talk with the expectation that everyone has some general idea of what lab notebooks are. I imagine you've come across the concept in some point in your education, or that you've used them in labs or perhaps in your professional life. I imagine that there are people in the computational sciences community that have already developed lab notebooks, for instance. So just to make sure that we're all starting out on the same page, there's this quote from Howard Canare, where he says that a goal of keeping a lab notebook is to write with enough detail and clarity that another scientist could pick up the notebook at some time in the future, repeat the work based on the written descriptions, and make the same observations that were originally recorded. If this is followed, then even the original author will be able to understand the notes when they look back after a considerable amount of time has passed. So that fits with my gut level understanding of what a notebook is. I hope that sounds familiar to you. I would say that this is fairly minimal in the sense that what he seems to be describing is something like a cookbook. Right? We're going to be developing recipes. We're going to be executing those recipes. Let's try to record all of that. And as we go through the talk, we'll try to see how we can try to expand on that original definition. So based on my experience of having this discussion with many different people, I don't want to just jump off with lab notebooks. I think there's some background information that we want to have and set forth so that we come to a common understanding and can build upon this to understand why documentation might be useful for us, and in particular why lab notebooks might be useful for us. So the first thing that we're going to do is just try to look at these normal words that we use every day: data, information, knowledge, understanding, and wisdom, and try to arrive at a common definition or a common understanding of what those concepts are, because these are words that we use daily. We oftentimes use them, I think, in wishy-washy ways, and sometimes we'll use these words interchangeably. So in particular, what we're going to be focusing on is trying to really converge onto a common understanding of what knowledge and understanding mean to us and how they're different. Okay? So we're going to start off with data information. Data is a collection of numbers, symbols, what have you. Data in and of itself has no value. Its value is simply in the fact that someone has taken the time to record it, or some instrument has recorded it. It exists, and hopefully it's been made available so that people can actually put that data to good use and derive value from it. So for me, information are facts that are gleaned from that data. We probably arrive at those facts because we're trying to answer certain questions like how, what, when, how much, how long. And so if I take an example, if I take time series data, representation of temperature, relative humidity, and precipitation, if I pore over that data long enough, I might arrive at these certain facts, this information, which is that starting at 2 p.m., the temperature dropped by 5 degrees Fahrenheit over 15 minutes. 5 minutes later, it started to rain, and 1/4 of an inch rain was accumulated over the next 30 minutes, right? So hopefully we get the idea that that sounds factual, and it certainly is answering some of those questions, right? So we're all on board at the moment. Not too, I think, earth-shattering at the moment. So knowledge and understanding, these are concepts I think are harder to define. I think we're really just going to have to work through these examples and talk about it a little bit so that we arrive at more of an understanding, a gut level understanding of what these concepts really represent. So knowledge for me is something that's derived from information and experience and understanding. So unfortunately, I'm going to be defining knowledge in terms of understanding. So for instance, if someone gave me that information from the last page, and I had sufficient understanding, I might generate the knowledge, which is when relative humidity levels are high and temperatures drop substantially, there's an increased probability of precipitation, right? So I don't know anything about atmospheric science or meteorology. If you gave me that information, I could probably generate that, but I would argue that that's probably speculation. Why? Because I don't really know much about meteorology, and I can't really substantiate it. And I think that's where the understanding comes in. Someone who has a good background in atmospheric sciences, who has practical experience in that, can generate that from the information. And because of that background, they'll be able to answer why that knowledge is probably true. Their background and their knowledge will allow, or understanding will allow them to substantiate that and elevate it from mere speculation to knowledge. Okay, and what's more, for instance, they'll probably be able to do that at a broad level of details. And so in this particular case, what I'm imagining is that they've generated that knowledge at a level of detail for someone like me, so that I can make general decisions as I go through my day. Okay, so one of the things that we've talked about here is that someone generated knowledge, they wrote it so that it could be shared, and they did share it, and hopefully I can understand it. But a question for you is, can someone actually share understanding with you? I think you'll get the idea that probably no. right? What we can do is share knowledge. We can create an environment in which we share that knowledge, in which we help people so that they can create understanding themselves. Okay, so are we more or less on board with what knowledge and understanding is? We can't explain it in words, but we more or less think we got it, right? All right, cool. So here's my obligatory Einstein quote. Any fool can know, the point is to understand. So I like this quote for a couple reasons for this talk. One is because it seems like his understanding of knowledge and understanding are in line with what we just talked about. Somehow knowledge seems to be easier, understanding seems to be harder. Okay? But this question also makes me wonder, as I go through my life and I'm making decisions, should I only be satisfied if I have understanding? Or is mere knowledge sufficient in some cases, right? So hopefully you'll understand, you'll come to the same conclusion as me. Sometimes knowledge is just good enough, right? So some atmospheric science shared that knowledge from the previous page with me. I have general knowledge that's sufficient for me to make good decisions every morning about whether or not I should bring an umbrella with me, right? I don't need to study meteorology to do better than that. So this leads us to the next slide, and we've heard this phrase in the morning as well. Sometimes what we want is just good enough, right? Sometimes knowledge is good enough. So if we try to put this into more concrete and relative example here, let's imagine that we're on a team of developers, and we're all working on the same software. We're all trying to interact and communicate with each other through a Git version control system. And we acknowledge that sometimes that interaction through Git can be very challenging. So what we want to do is to come up with a Git workflow, which is a set of rules about how we use Git, how we interact through Git, so we're not stepping on each other's toes and breaking the code. So we don't need everyone on that team to be experts in Git, right? What we want to do is have a subset of that team have sufficient understanding of Git, to have sufficient understanding of how it's difficult for us to interact through Git. And we want those people with understanding to develop that Git workflow. And if they've done it well, then all of the other people on that team can operate and use those rules even though they only have minimal Git knowledge, right? They can have a minimal amount of Git knowledge, use Git in a nice, respectable way, following those rules, and hopefully they won't do any damage, which is great because then all of those other developers can concentrate just on what they want to do, which is develop and test the code, for instance. And if we have newcomers coming in, the bar for entry is hopefully fairly low because they don't need to be experts in Git. So this DIKUW, this classification scheme, it's a part of a broader area of study, I guess, called knowledge management. I don't know entirely too much about it. If you look back on that slide, they now call it DIKW pyramid. I don't know why they got rid of the understanding. Hopefully what we can see is, what we want to do is to try to acknowledge that knowledge management is important. We want to be sharing knowledge, for instance. And so what we can try to do is build it into how we work and work with each other. So fundamentally what we want to do is recognize every time we generate a new piece of knowledge. Not only do we want to do that, but we want to capture and preserve it so it doesn't just float off as it escapes from our memory. And we want to try to hopefully communicate that knowledge so that we share it and others can benefit from that. So in terms of all of these three things, obviously you have to recognize when you're generating knowledge. If you don't recognize that, then you don't have to worry about the other ones. But I will actually point out that I think that that's really quite hard. I think oftentimes we're generating knowledge, but we don't even know it. So that's one of the first steps, I think, is to try to tune your mind to gain the skill where you can be listening to a talk or be in a meeting where you're brainstorming and realize, oh, that was knowledge. That's something that we really should be writing down. We don't want to forget that, right? And so a common question then is knowledge communication only about communicating to others? And based on that minimal definition of lab notebooks, we understand no. Sometimes we want to communicate with our future selves, right? So data, information, knowledge, understanding, and wisdom, that's really sort of high level and abstract. It's nice. It's clean, at least for me, in terms of thinking. But can we relate it a little bit more closely to our real lives? And so an example of that is lessons learned, which I think we've all heard about. The idea is that we go through some sort of an experience. That's great. We learned and we grew from that experience, but we want to try to do more. We want to try to get more out of it. So what we can do is sit down, we can be thoughtful, we can reflect on that experience, and we can try to derive lessons learned. And I would argue that those lessons learned are nothing more than knowledge, right? And we want to use that knowledge so that we can grow, improve, and avoid difficulties that we made, all with the hope of trying to improve our understanding. And so if we did this together, we went through this experience together, obviously we can try to do that as a group so that we can create better and more high quality knowledge. One of the benefits of doing that in a group is that the communication of that knowledge is implicit. It automatically happens, but we shouldn't be content with that. We should try to write that knowledge down and share it to other people who weren't involved, right? So that leads us to documentation. Obviously, lab notebooks are a type of documentation, so we're starting to get there, right? So I did start learning about knowledge management and this classification scheme probably 10 years ago when I was working at the observatory. We had a real problem with trying to make sure that we were capturing and communicating knowledge across all of the different groups, right? And so one of the byproducts of learning about this is that I started to sit down and think about how documents, what are they for, how do we use them, and you start to realize that documents they play different roles, they're different. And one of the things I also started to realize is that we can actually start to sort of assemble the different types of documents into something that I would call a hierarchy of documentation. And that's what I've tried to draw here on the screen. It's a cartoon representation of what a documentation hierarchy might look like in our lives. And at the very bottom level, what we have are documentations in the form of emails, Slack messages, ticketing systems, so Jira, for instance, if you use that, and commit messages. And what do these have in common? Well, these are documentations or activities that we carry out quite common, almost on a daily basis, sometimes on an hourly basis or less, okay? Which means it's quite extensive. We're going to have a lot of documentation in that form. It also means that there's a lot of different types of documentation there, so it's really quite large and dispersed in that sense. The other way to try to think about what these have in common is to imagine the scenario that I come in on a Monday morning and there's some nasty bug that I want to try to debug. And I realize that it's going to be nasty enough that I'm not going to just try to do it flying by the seat of my pants. I'm going to write comprehensive notes so that I don't get lost and I don't start going in circles. And let's imagine that it took me 5 days to do that. And I took 5 days of comprehensive notes. That's really a lot of notes, right? That is large in that sense. What's more, those notes are probably going to be pretty dirty because on day 1, I didn't know what I was doing. Whereas on day 5, my notes are probably going to be pretty good. So the value of this documentation is that it's comprehensive. The trade-off is that it's dirty and noisy, which means that when we encode knowledge into those notes, it's going to be extremely hard for someone to find. We simply can't expect that people will find that knowledge there. So what we want to try to do is to filter out those dirty, large notes every now and then and condense them into a higher level of document like issues, pull requests, and developer documents, right, where there's less noise. They're cleaner, they're more concise. Hopefully people will be able to find that knowledge there and benefit from it. And then again, we can just keep going and doing that until finally we get to the top where we have articles, which should be very clean. They should be very concise, right? And that's where there should be a lot of knowledge buried into that. So what we see to some degree is at the bottom we have data. We move up. What we're trying to do is create cleaner and better knowledge that's easier to find, okay? Some other aspects of why documents are different is that some are frozen at creation, like emails or commit messages. Some of them are living. So for instance, a developer document, when we start on a project, we can write that. We shouldn't make the assumption that what we thought about at day 1 was going to be valid. As we grow and the problems, challenges change, we should always maintain that document up to date so that when people go and read it, they know that it's correct and that they should use it. So one of the realities of me learning about this and figuring about this is that I really understand and have an appreciation of just how difficult it is to do documentation in a digital distributed world. So now we're at the point where we can start talking about lab notebooks. So where do lab notebooks fit in onto that hierarchy scheme? Well, lab notebooks should be something that we're using regularly. They should be comprehensive and they should not be filtered at all. So human beings, we like to think that we're very good in the moment of knowing what's going to be useful in the future and what isn't. I think the reality is we're quite miserable at that. And so that's why the insistence is that they be comprehensive and never filtered, right? You never know what's going to be valuable. You don't need to have perfect grammar here in a full sentence. You can just bullet point things, right? The idea of making it efficient. And the content is frozen at creation. You're not supposed to alter it in any sort of a way. So hopefully we understand that this locates the lab notebooks very firmly at that lowest level of the hierarchy, right? And there's some other aspects to it. So for instance, I mentioned at the beginning that you can think of it as sort of a cookbook, but we want to do better than that. We don't want to just write down, this is what I did, this is what I did. We want to try to put in motivation, reasoning, conclusions, and assumptions, for instance. The idea is that we're not just recording our actions, but we're going to try to dump into that notebook our state of mind at that point in time, with the idea that that's a communication to my future self and to others, that 2 years down the line, I can go back and read this and hopefully reload that mental state there so I can understand not only what I was doing, but also why I was doing it. Okay, so lab notebooks for me, they are a fundamental part of communication, of rigorous reproducible science in a lab. They're commonplace in experimental laboratories and in some environments I imagine that they're required. And I also imagine that in some areas of computational sciences, they must also be required in some form or another. They are generally a tool for preventing scientific fraud, and there are some legal aspects of notebooks if you carry them out correctly. They can be a record of invention, for instance, for patents, and they can also help defend you against allegations of fraud. So I will mention at the observatory, which is a very much larger place, a very larger scope, there is no single lab notebook. We had something like 20 different scientific instruments. That just wouldn't work. And so there was a group of experts who came up with an automated system where it would be acquiring data automatically and essentially assembling a lab notebook. But I wrote it in quotes because it was never completely automatic. They still had to go and create some tools that the people who were operating the telescope and guiding the observations at night, where they could take their impressions about what they were seeing, what the conditions were, and try to put into those tools why they were making certain decisions so that then that could be inserted into these larger observatory-wide lab notebooks. So because these lab notebooks are on the bottom scale, they're not very great at communicating knowledge, but there's another point that I want to point out, that there is a sort of implicit communication that happens with lab notebooks, which is very rich and very nice. The idea is if you have a group of people who are collaborating actively through the lab notebooks, they're reading what everyone else has been doing. They're seeing how they're thinking, how they're approaching different problems. They see how they visualize the data, and sometimes they say, wow, that person really came up with a very nice visualization of the data. It's very easy for me to see what they wanted me to see in the data. And so you start learning from each other, and eventually people just start to converge on this nice work style, right? I think that's very important. So some examples of lab notebook entries. On the left, I put something that's quite miserable. So on Monday, I told you at 9 a.m. that I wanted to do a study called ABC. And some 12 hours later, I told you there was lots of interesting data, and I just left the data somewhere on some file system called GCE. That's great. You told me that you did some work. Well, I told myself that I did some work. But this is going to be useless to me in a year's time. And if there's multiple people acquiring data in this study, it's going to be fairly useless to them too. And if they're doing the same thing, we're going to have a hard time trying to figure out how all that data was acquired, why did we acquire some of that data, what did we see in the data, right? So what we can try to do is something on the right, which is a little bit better. So that same day I came and I told you I was continuing work for study ABC. I'm being nice to you and telling you that if you want to figure out where we left off, go see July 7th. My current impression is that if A happens, then B must also happen. And then we're imagining here I'm bullet pointing an experiment that I would like to carry out in order to convince myself whether or not that relationship is true. At 9:30, that's where I start exercising that, executing that recipe. So I tell you I'm going to be running this on a system called Bebop. I'm going to be using a debug version with Intel. I'm building in a clean commit, this, and I build it, and I tell you that I put all of the build output in this nice log file. So this is where things in computational sciences can be nice. That log file ostensibly contains a lot of different lab notes. But in this case, I can automate that procedure. I can just ask the build script to actually save that to a file and capture it here. And then all I have to do to make my life simple is tell you to go look at that part if you want more information. Then below that, I told you that I actually went through those build logs and I determined there were no errors or warnings. So at this point, you guys might say, well, that might be obvious. Just go and check the logs. Why would you take the time to write that down? There's some utility to me putting this down. I'm not just telling you that there were no warnings. What I'm telling you is that it occurred to me, first and foremost, that I should actually check that there are no warnings. And then I'm telling you that I did it, and then I'm telling you that I didn't see any warnings. So this is a place, for instance, where learning might happen. So if you have someone who's just coming into this community, and they haven't adopted this habit of going and checking their logs for warnings, well, now they might read this and realize that they should start doing that as well. Okay? So now we can go through, I start running it, I get this job number using this configuration, I tell you where I store it, and then I start to do some visualization, and I say that I didn't see a peak around 1.5 MeV, which is my way of knowing that this was my hypothesis was incorrect, but now I can amend my hypothesis, and now I say that if A is correct, then C must also be correct, and you can see where this would just start repeating essentially. Okay, so not all documents are alike, not all lab notebooks are alike. In some cases, what you have is a lab notebook where all you're going to be doing is recording the work that's done on an instrument to develop it, to maintain it, to characterize it, to configure it, things like that. But we can also have lab notebooks that are dedicated to really recording just the acquisition of the data, how we use that instrument, right? So we can have different types of, I'll call them streams of lab notes, right? And we can choose to put them in 2 different lab notebooks. And this is an example I found. I went back to the observatory where I worked, to their web page. looked up an instrument named Criris that I used to work on, now known as Criris Plus, and I find that they have this lovely lab notebook, which I will call a filtered lab notebook for users. This exists a little bit higher up on that documentation hierarchy. The idea that there are multiple teams that work on this instrument to help it produce scientific data for the community. And each team, you can imagine, has their own comprehensive lab notes. And if you tried to give that to the scientific community, they wouldn't know what to do with it. So someone has gone through and filtered all of those lab notebooks, plucked out what's useful for the users, and put it into this nice, concise little example. So for instance, if you're a user and you took some data, let's say in February, and then you repeated that exact same observation later in May, and you see some change in the data, you shouldn't get too excited yet because it might not be a change in the physics. What you should do is come here and see that maybe on May 5th, some people were intervening the actual hardware. Or perhaps people who write and maintain the data analysis pipeline change their algorithms in a way that might explain the different changes that you see in the data. Okay, so what is the reality of lab notebooks? Then I would say documentation in general. The reality is no one likes to use them, right? It's boring. It's a lot of effort. People don't normally appreciate it. And I've gone here and I've tried to put up a summary of what I think is a realistic explanation or summary of our relationship with documentation, which is we love to consume documentation. Write it? No, thank you. I'd rather do something else, right? So I've got an optimistic explanation for that relationship and a cynical one. We'll start on the happy side, which is that there's probably a lack of experience and training for writing technical documentation in general. In an experimental laboratory, there is some notion of training to teach you how to use that notebook, and you learn from reading them, certainly. I think there's also a lack of appreciation in terms of documentation and lab notes. In the case of lab notes in general, the common perception I've come across when people start to use them is that they're useless. The idea is that they tell me that they're writing a lot of data into this and then they're never coming back to it, so why should they be doing that? There's a couple reasons for that. One is if you've only been using a lab notebook for a month, you don't have to worry about it because you're not out to that point where your future self needs to look back because you've forgotten things. Another thing is because oftentimes people don't appreciate that there's that implicit communication and learning that goes on through the lab notebook. And finally, I think the main point is the lab notebook is there and its utility is highest when something has gone catastrophically wrong. So if you're not going back and rereading your notebook on a regular basis, that's a good thing. You shouldn't be, see that as a negative thing and motivation for not keeping good lab notes. So, the cynical side is that if you allow me to rephrase this in terms of knowledge management, that we all love it and we appreciate it when others take the time to share knowledge with us. However, I don't want to take the time to capture, preserve, and communicate knowledge with others that I've generated. So that sounds depressing, and it is depressing. I hope it's not true. And I hope it's not true because this is really missing out on one fundamental aspect of productivity as far as I'm concerned, which is the case when one person sacrifices their short-term efficiency for the benefit of many other people, so that those other people can improve their efficiency, and the team can improve their efficiency and quality in the long term. So if someone really is coming up with this view, I would say that they're short-sighted because they're only focusing on the short-term benefits to themselves and not on the long-term benefits for themselves as a member of a team. Okay, so back to Carlo. Again, I mentioned that he wrote a BSSW blog article, HPC and the Lab Manager. I've read it several times. I would recommend that people go and read it. It's very interesting. So after reading that and having several conversations with Carlo, my understanding of his point of view and his perspective was that as researchers' careers progress, they start to work on ever more complex, large, complicated problems. The informal techniques that they had used previously to help them execute that study start to fail. And they get this sick feeling in their stomach that something's gone wrong. This isn't sufficient. This isn't how I should be doing science. And what he says is that they generally invent processes and tools to help them compensate. And this happened to Carlo, and he started to invent some tooling to help him for his next study. And he was thoughtful and realized that what he had done was actually reinvent the lab notebook, right? And so as I have had other people read this, and they come back very enthusiastically, and they say that really his experience resonates with their experience very well, as much. So now the rest of the talk is going to be me sort of giving you an idea of the pros and cons of lab notebooks, the challenges associated with them, so that we can start to build up for how we might use these in the computational science world if we choose to. So my belief is that nothing will ever beat good old pen and paper. That's not because I'm being nostalgic. That's not because I'm a Luddite or I'm being closed-minded. I no longer use paper lab notebooks, unfortunately. I haven't used them for probably about 7 years. But really, there is nothing better. You guys will probably never convince me otherwise. So why is that? Well, the reality is the paper and pen is easy. Almost anyone can take notes in paper and pen. There's no excuse. They're not dependent on much else. If I have a pen and I have an adequate light, I can start taking notes. Yeah, go ahead.
What about like GitLab and GitLab Wiki? So
In terms of writing lab notes?
Yeah, so like everyone here, I'm assuming, works on an HPC system.
Yeah.
Right? So the most obvious thing that we have access to is a GitLab or like some type of like Confluence type. I'm not saying people
you actually have a huge number of tools if you think about it.
Right. So, but when we do like GitLab commits, right? Yep. That's like one way. But another way is that if you're using GitLab, you have, like other tools that are available.
You have issues, you have PRs.
If your organization is paying for the paid version of GitLab.
Yeah.
So, what is the incentive? I haven't found an incentive.
So I'm getting to that yet, right? So I'm working up from the most basic one, so that we can understand what is good about that, what we want about that. What I'm going to get to at the end of this talk is that paper will never work. And that's why I haven't used it for 7 years, right? And then that gets back to that documentation hierarchy because the lab notes is at the bottom. It's large and it's distributed. How many tools do I have, right? Should I only be putting all my lab notes through Git commit messages or should I actually put them through different, right? These are the challenges of trying to take this type of lab notes in the digital world where you can't use paper in particular. So I'll get to that hopefully. If you have any questions, if I didn't address it, or you've got more comments or some ideas, please let me know once I get a few slides down the road. Okay? So why did I like pencil and pen and paper? Well, because like I said, it can be used in any situation, right? The other thing is it's just a blank piece of paper. So it's a completely open format. Nothing's trying to dictate to me how I should keep the record. Nothing's there to restrict me or to color how I want to do that. It's completely open. I can use all of my creativity. What this means as well is that I can concentrate just on the work and writing notes simply and easily. I don't have to concentrate on tooling or how I'm going to manage this. It also can be, I think, quicker to scribble down notes. Again, notes don't have to be perfect, right? This is at that lower level where things don't have to be polished. Another thing, and this aspect is potentially just for me, I don't know. I find that when I take lab notes, it does slow me down, but that's a good thing. It forces me to, the act of writing it down forces me to think in better detail about what I'm doing. I won't make as many mistakes because I'm going to think about potential problems earlier on, and I'm going to catch more subtleties, right? So even if it is slower, that's probably good. The other benefit of this is that the notebook is always stored next to the instrument where it's used. It's public, right? That's an important aspect of a lab notebook, that it should be public. So I really am not the only person who thinks that pen and paper is better. There's this article from Nature, I think it's from 2018, where they say that people have been predicting the death of the paper notebook for decades, and it just simply hasn't happened. It's only happening sort of recently, and that's not necessarily because it's a better solution, but because a lot of people have this idea that our tools should better be digital, and somehow paper, I think, is anachronistic and not acceptable. There's a lot of different things in there about this that give you some idea of how you can choose an electronic laboratory notebook and the reasoning for some groups choosing a particular lab notebook. I've put down here the three that are probably the most interesting. So one thing that they point out is there's an overwhelming variety of tools that you can choose from, each with their own pros and cons. And so they say it can really be overwhelming just trying to choose one. And if you imagine that those tools are evolving and changing over time, maybe you're having to do that reevaluation on an annual basis, which can be very challenging. For me, the biggest thing is there's a huge amount of uncertainty about a future tool. I might like it one day, and then they might evolve it in another way where it stops to be useful for me. If really a lot of people start to use it, they might suddenly triple the cost of it, and what do I do? And finally, if I do have to change tools and I need to export my lab notes into the next tool that I'm going to be using, I might not have that ability, right? Another thing that they put up there that I thought was kind of interesting, based on your funding restrictions, there are some tools you might or might not be able to use, okay? A final mention about this is, for instance, they have templates, which I think are good. For certain types of science that you're doing, having a template is good because you really are just repeating the same recipe. But what I don't like about templates is that makes people's minds turn off. They lose their creativity potentially if someone throws a template in front of them. So what would a laboratory note look like for us? Well, paper won't work, right? It just won't do it, unfortunately. We're not sitting next to a single instrument in a single laboratory. We're multiple people in a distributed world, right? So we need something that's digital. So I do talk with a lot of people, and they tell me that they are keeping some sort of notes, not necessarily lab notes, but they're doing it. But usually what they tell me is that they're keeping those notes private. Their collaborators and their coworkers don't even know that they're necessarily keeping those notes. Is that acceptable? Should it be public, right? If it's not public, then you're missing out on, well, one thing, preventing scientific fraud. You're missing out through that implicit communication that happens, right? You're not getting people giving you oversight about whether or not what you're doing is good or sufficient. So how do we make it public if that's what we choose to do? As I also mentioned, how many different types of notebooks do we have? Do we have one just for the instrument and one for the acquisition of data? Or do we have multiple different streams? Are we going to use a single digital notebook, or are we going to distribute them across a suite of tools? So I did start off by trying to find just a single tool when I came into the computational sciences world. And I started to come down after about a year of liking Microsoft OneNote. And if you go and read that Nature article, actually several people said that they settled onto OneNote. But I really did find out that that was not sufficient. One tool was not going to cut it. I really needed to have a multiple different number of tools. And we're going to go over these two topics in the next talk. The next talk is really going to be a continuation of this one. So here we're just looking at pros and cons, and we're going to come up with some questions. Obviously, one of the things that we can try to do is to figure out how to automate appropriately taking lab notebooks so we can make this as easy as possible, decrease the rigor or the tedium, and try to also decrease some of the risk. So down here at the bottom, I've actually put an example of me recording lab notes in one of the repositories that I work on. And this is, I'm doing it in a commit message, right? So what I've done here is, this is the style that I'm currently liking. Up top, I'll put what might be a more typical portion of a Git commit. So I'm going to put in details that people cannot reverse engineer out by looking at the diff of that commit. So I do put in things like motivation, reasoning, and consequences. Any assumptions that I made particularly. If I'm changing a requirement, I might put that there as well. Then at the bottom, I'm putting more, let's say, recipe part. And this is potentially a different part that you might not see in other places that is perhaps more rooted in scientific work than, let's say, in software engineering. And here I'm telling you what I did to convince myself that the changes I made at this commit were correct. So I ran a certain set of tests on this machine using this compiler. The tests I actually had to manually verify whether or not they were correct, so I told you. So what am I doing here? At this top part, I'm telling you, I'm trying to load into the git commit message my mental state at the time. Right? Why did I make these changes? What guided me to make the changes in this way? What were my assumptions? And then one of the reasons why I like these is because when I come back and I want to do my own code review of a PR, I'll first start by just reading all of my commit messages. So I'll load in my mental state. I generally find that that helps me get a really broad overview of what I was trying to do and what work I did to check to see if I had done it correctly. Okay? So is that kind of what you had in mind?
Yeah, I guess. I mean,
Yeah, okay.
So here's the citations, which means we're at the end. I put in some meta conclusions in terms of knowledge management. I did not develop this module with the intent of me sharing knowledge with you guys so that you could immediately go forth and just execute whatever you wanted to. This was a talk that I developed where I would, relating my experiences, I related knowledge to you with the hope that this would help build understanding so that you guys could try to figure out what's good for you. Maybe what you're doing is already good enough. So like I said, here what we were doing was really establishing concepts, pros and cons, asking questions. Hopefully in the next talk, we're going to start actually making those a little bit more concrete. And here are my actual conclusions, which I won't read over, and I'll just ask you guys if you guys have any questions at this point. Can I just ask a question? How many people actually use lab notebooks here? I do believe that there are parts of computational sciences where it's probably required. So we have 1, we have 2, sort of, 3, sort of, 4. Does this resonate with you guys at all? Yeah? Is it a fairly painful experience still? Yeah, okay. That's kind of what I thought. But it's good to know that people are out there doing this. Yes?
I kind of do have a related question. Is what point does this become data hoarding? How long do you hold on to these notebooks? That's a question I've asked a lot in my own life. And, is it when you're finished solving a problem? Is it when the paper is written? Is it when the paper is accepted 5 years after,
So to some degree, that depends on, I think, some of the fundamental needs for why you would use a lab notebook. So in some cases, it is legal in scope. And so I don't know anything about that, right? But if you are, for instance, using that to prove some date of invention, then there might be some legal amount of time for which you would need to keep it. I would also say, for instance, after I've written an article, I don't want to throw it away, because that article will hopefully have some life for a number of years. It's entirely possible that for who knows how long, 10, 15 years, that someone might call into question the work that I've done, or I might myself call into question the work that I've done, and I might want to go back and review it, right? This is part of it, is you never know what's going to be useful, right? There are certain notes, for instance, that I would throw away. So for instance, debugging. Like I told you, there's that 5-day thing. I might not keep that. If there was something interesting, like I invented a new trick that I haven't done before, I might take that, call that knowledge, and put that in some other notes, and then just throw away the notes, for instance. I don't consider that debugging to me is not necessarily part of the scientific record of the instrument in that case.
Sure.
Yeah.
I'll just mention at ORNL and probably at the other DOE labs, they have both paper notebooks, and they now have electronic notebooks that are kind of blessed and managed by the organization. They're considered permanent records, literally. So when you fill up a notebook, you're supposed to, well, you can keep it, but then eventually, even when you leave the lab, you're supposed to check it in with them. They put it in a warehouse somewhere, and actually I happen to know where that warehouse is, but it's, down the road in Oak Ridge. There's an organization that does this kind of archiving for the whole of DOE. It happens to be based also in Oak Ridge. And so in some cases, these really are permanent records.
Okay.
One of the strengths I think of Git is the ability to, make a commit every 10 minutes if I want to, but I don't want all of those commits to go. To go to the repo, so I squash or rebase or something. Is there a better way to keep that stream of consciousness nodes besides just backing up a branch and then ignoring it for 10 years?
Well, so this is a broader point, which is that you have a way that you want to use git commit messages. I have a way that I want to use git commit messages. And that's part of the difficulty. If we want to make git commit messages, like in our group, we want to make git commit messages part of the lab notebook record, we all need to be on board with that. And we all need to use them in that correct way. So if someone were to come through and squash, then that record is lost, right?
So one of the things that we are working on with Boyana is going to give a talk about the tools we're building, and one of the things that we are actively working on building in terms of tooling is exactly addressing your issue, in that she's building a pull request assistant, which will try to consolidate all of the commit messages that are related to that particular PR and summarize them in usable ways so that all of the raw commit messages that you had before do not need to be preserved.
In my wildest dream, the idea was you would put the different streams of lab notebooks in the tool where they should go. And we'll get into that in the next talk. If there could be a tool that could then collect everything up and actually essentially write my good old pen and paper so I could read it in a chronological or search it in that way, I would be over the moon, right? Then I'm not having to go through and figure out where all the different data is, right? That can be overwhelming, but that's, I think, our reality. Like I said, it's difficult to do documentation in a digital age, I think.
Because one of the issues that happens with the documentation also is that if you don't do it in an organized way, then having done it is useless. Because if you can't find it when you need it, what's the point of having it?
Thank you for your attention. I appreciate it.